Welcome back. We are now going to discuss wireless networks and security issues faced by them. We're going to start off with wireless LANs. We're going to see their different architectures, and we're going to see some of the security challenges faced by wireless LANs. So a wireless local area network basically extends the corporate backbone local area network for users who are mobile. So the basic idea is that we have users who are mobile and they need to access the backbone LAN. So that's why we install wireless access point at different locations which are connected with the backbone LAN, and these wireless access points, they extend the coverage of the wired network to a bigger region. So wireless access points, they basically connect wireless clients to the wired network and they act as the intermediary between the wireless and the wired domains. Now this architecture is flexible because whenever you need to extend the coverage, you just need to add a new wireless access point and you have new area which is covered. A related concept is SSID. So this is the name of the wireless network. So even if you have multiple wireless access points which belong to the same wireless network, all of them are going to broadcast the same wireless network name. And all the clients, no matter where they access the network from or where they see this network, they're all going to see the same name. A related concept is BSS or basic service set. So a basic service set is basically a group of stations connected to a wireless access point. So for example, in this figure, we see that this is BSS1. This comprises of this wireless access point and its associated stations, and this is BSS2 and this is BSS3. So basically a wireless local area network comprises of different basic service sets and together they form the overall network. Let's discuss unauthorized access challenges in wireless networks. So the first challenge is malicious association or a rogue access point. So a malicious user who is insider in an organization can basically connect a rogue access point to the backbone LAN. Now this access point can be a laptop with specialized software running on it in order to simulate a wireless access point, or it could be a purpose-built hardware-based wireless access point. In either case, the basic purpose is to trick users into connecting with this access point instead of the legitimate ones, so that the malicious user can steal usernames, passwords, and traffic. Now, for this attack to be successful, you obviously need an insider who needs to place this wireless access point within the boundaries of the corporate network and connect it to the backbone LAN. Another issue is MAC spoofing or identity theft. So basically the idea is that, unlike wired channels, sniffing traffic on the wireless channel is much simpler because the waves are everywhere. So a malicious user who is located nearby at a strategic location can sniff wireless traffic and identify the MAC addresses of the stations, and then he can masquerade as a legitimate user. So for instance, in this example, this legitimate computer is communicating to the wireless access point over the wireless channel. A malicious user eavesdrops on this wireless channel, captures the packets using wireless sniffers, and then he can deduct the MAC address from there. So based on the MAC address extracted from this information, now this malicious user can use the same MAC address and pose as the legitimate user John. Another popular attack in wireless networks is wireless man-in-the-middle attack. So the concept is actually very old and this works for both wired and wireless networks. The basic idea is that there is a malicious user in between who basically replays traffic after copying or modifying the traffic. So the basic idea is that none of the two end stations have any idea that there is a malicious user between them because he simply relays the traffic. Now he can do a lot of damage. He can either, simply copy the traffic and steal credentials and other information, or he can go one step ahead and actually modify the traffic in order to cause further damage to the end systems. We are now going to have a look at some of very basic security features which could be used in wireless networks, but we are also going to highlight their limitations and why they are no longer considered a good solution. So the first solution is SSID hiding. So you see, whenever you turn on the Wi-Fi on your laptop or your mobile phone, it takes a few seconds before you start seeing wireless network names. And that's because the wireless access points, they periodically broadcast a special frame called a beacon frame roughly every 30 seconds. And that beacon frame contains the SSID, the name of the network, the wireless access point's MAC address, and the IP address. So it is that SSID which you received in the beacon frame through which you see the name of the available networks near you. Now, one solution could be, if you just hide the SSID and disable the beacon frame so that, users who already have this network logged onto their devices, only they can connect. This works, but it's a very basic protection because, even a simple wireless sniffer can capture packets and identify the MAC address of the wireless access point. So hiding the SSID or the MAC address of the wireless access point is not a very good solution. Another simple option could be you could use MAC filtering. So the basic idea is that, unlike IP addresses, MAC or physical addresses are physically burned onto the devices. So if you have a mobile phone with a network interface card, it will have its own fixed MAC address. One simple solution could be you could add a list of known or authenticated MAC addresses to a whitelist. And I've observed this solution at a number of places. Now, this solution worked well a few years ago, but now there are many different solutions. So basically, again, a sniffer could be used to extract the MAC addresses of legitimate stations, and then there are specialized tools and softwares which allow end systems or malicious devices to masquerade their MAC address. So they can actually change their MAC address to the one of a legitimate user and again connect to the network. We are now going to have a look at some of the security encryption schemes for Wi-Fi networks, and we're going to compare and contrast them and identify their weaknesses as well as strengths. So the first solution that was proposed for wireless networks was WEP, or Wired Equivalent Privacy. Now, it was the original wireless encryption standard for wireless networks. This was the first time that a solution was proposed specifically for wireless networks, but it offered weak security. But that's understandable because, encryption was very matured in wired networks, but for wireless networks, it was a new arena. So a few years ago, when WEP was originally proposed, this seemed like a good solution. However, as time progressed, lots of vulnerabilities were identified in WEP, and that's why it was no longer considered to be a secure solution. And in fact, WEP has been shown to be broken in a few seconds. Another limitation of WEP was that it used very short keys, 40 to 104 bits. So the next protocol which was proposed was WPA-TKIP. WPA stands for Wi-Fi Protected Access. Now, Wi-Fi Alliance, this was a consortium of different companies which basically came up with the term Wi-Fi. And they sat together to address the weaknesses of WEP, and they came up with WPA-TKIP. So the first thing that this new solution did was to increase the key length. Because, always remember, in encryption, the longer the key you use to encrypt, the stronger your encryption is. If you use a shorter key, your encryption would be weak. Another important contribution of WPA was the TKIP protocol, which is the Temporal Key Integrity Protocol. This is a very interesting concept. What it does is that it generates a unique 128-bit key for every single packet. Now, this does seem like an overkill. However, given the power of processing that we have now, it's very easy to generate new keys. So basically, this is the concept in which we generate keys for every different packet. So you can imagine how hard it would be to break it. But we still saw that there are vulnerabilities even with WPA-TKIP. I mean, it's not as easy to break as WEP, but there is still some structural problems. One of the key problems was that this solution still derived a lot of its features from WEP, which had some inherent flaws. And that's why WPA-TKIP is still considered a relatively weak solution. The final solution in this category was WPA2. Again, Wi-Fi Protected Access version 2, which significantly improves upon the WPA. So one of the key features of WPA2 is that it uses AES encryption, which is an industry standard, state-of-the-art encryption algorithm, very hard to break. So that's why this is generally accepted as a secure wireless encryption standard, both in government, in the industry, and even for military. If we compare WEP, WPA, and WPA2 in terms of features, so in terms of the key length, WEP offers the shortest keys, whereas WPA and version 2, they offer relatively longer keys. Now, WEP offers the weakest security, WPA improves upon that, but the best solution is WPA2. Another important difference is that WEP used static keys. So basically you use the same key throughout the session, which is a bad idea. In WPA and WPA2, we have dynamic session keys which are rotated. So one of the fundamental problems with WEP is that it used the RC4 encryption algorithm, which had some inherent weaknesses. And WPA also used the same algorithm. That's why it's also considered relatively weak. However, WPA2 uses the AES encryption standard, which is a state-of-the-art solution for encryption, and that's basically where it derives its strength from. So generally speaking, if you need to select a wireless encryption solution for Wi-Fi networks, so WPA2 would be the way to go. That concludes our lecture on wireless networks and security challenges. I'll see you in the next domain.